Today we are going to test out a trading strategy that is based on linear regression. In this strategy, we are going to find when the stock is in an uptrend using a linear regression model, and then use that to take trades. All said and done, we will find that at the end of this strategy, after our optimizations, the strategy makes a good return of 1.2% as opposed to a buy and hold of -8% when the underlying instrument is not doing very well. And this also beats the random sort of return of -9%. So let's get into the nitty-gritties of the strategy. If you have been following this channel, you know that we start with a setup where we trade randomly, and then we show how our trading strategies are an improvement over this random strategy. So let's look at the random strategy. Here is what the trades look like in a random strategy. These trades are totally based on a random order, and they are exited based on a fixed take profit and a stop loss of 0.1%. The green circles is where we enter a trade, and the red circles is where we exit a trade. And this trade, for example, was in a profit, but this second trade where we have a cross here, this was at a loss. And as you can, if you observe closely, as you can see, the losses were mostly in this region when the stock was in a downward trend. How do we find when the stock is in a downward trend and basically stop entering a trade based on that? Our idea is to use a linear model. For example, let's say we are standing here. Now we can use linear regression to fit a line in order to find what is the best linear sort of model or best line that sort of minimizes the squared error here. And as you can see, this linear model has a negative slope. So we can clearly make an algorithm which says that when the slope is negative, such as a case like here, we won't take any trades. And then there are cases such as here, for example, where if I draw a linear line, this will be clearly positive. And we can say that when the slope is positive, or when the slope crosses a threshold, we are going to take a trade. And this is the rule that we are going to follow in our algorithm. We are going to code up the algorithm, and the download link to the notebook is in the description below. So we will start with our usual setup, where we start with the Bitcoin data in a 5-minute time frame. And then we start with the first 1,000 data points in this algorithm. And now the first thing we need to calculate is the slope of a linear regression. What we are going to do is to apply this function called rolling slope, which is going to take the last 100 data points and then going to calculate the slope of the linear regression. We've defined this rolling slope function here, and what this function does is to calculate is to define the x and the y, and to call the linear regression model, and it returns the first coefficient of the linear regression, which is the slope. The second one would be the intercept. And so by using the apply function in pandas, we are able to do this in a rolling manner for all the values in this data frame. We calculate this slope just to get an idea of where to set a threshold. Based on a general idea, we set a threshold at around 2, but we are going to be able to sort of optimize that after we do an initial run of our algorithm. So just for visual purposes, we looked at some of the slopes here in this data. And as you can see here, when the stock is going down, this clearly sort of defines a slope that is a best fit linear line, and the slope is very negative. And similarly, when the stock is going up, it defines a very positive slope, which gives us an assurance that the algorithm is doing what we want it to do. If you have followed my previous videos, you know that I tested this random strategy, which gave us a sort of win rate of around 66% and sort of return of around 4%. Now, what happens if in this situation we apply our linear regression strategy? So we define this random linear strategy, and if you want to know how we sort of define our backtests, these are based on the backtest library, which we discussed in a previous video, which again I will link to in the description below. So if we use our backtest library and run the test, we observe that we have a larger win rate. So compared to 66% when we were trading randomly, we have a win rate of 72%. But our returns are almost similar. And why do we have a larger win rate? As you can see, we were able to sort of avoid trading in this area when the stock was sort of clearly going downwards. Of course, we took like one trade here because by that time the slope was not established. So that is the reason that we were sort of able to improve our win rate, but we did take sort of less trades. And this is a much smaller sort of number of data points, which is good for sort of illustrative purposes, but now we can look at a much larger time frame. So when we look sort of more at 5,000 data points here, and do the exact same thing, we observe that in this case, the buy and hold has a minus 8.8% return, and the random strategy does very poorly at minus 17%. Our linear regression strategy is better than random, but it does a little worse than buy and hold. So the next thing that we are going to try to do is to optimize this strategy. We are going to optimize it on a different data set so that we don't overfit. And and I made a previous video about how to excuse me, about how to optimize a strategy, and if you follow that video, you will know that we define this optimization function, which returns the final percentage return when we run the strategy using our variables. In this case, the variables that we are going to optimize over are the profit percentage, which is the take profit percentage, the stop loss percentage, and the window over which we run the linear regression. This is the rolling data window, so the last n points that we consider for the linear regression, and the slope threshold. And this is the threshold above which we take the trade, and I'm going to show you the code for the rule for entering the trade in a little bit. But this is our optimization function, and then we basically return how much of a percentage return we get when we run the function using certain values. And again, like for example, we decide that we are going to have a 1% take profit, 1% stop loss, a 20 linear regression window, and a slope threshold of 3 that gives us 0.3 as a percentage return. Now when we do this optimization with like 200 runs over using a random search algorithm, we get the best parameters. When we use those best parameters, and remember these are for a test set, not the training data that we did the optimization for, we get a much better return. So even though the buy and hold return is minus 8.8%, so the stock or the Bitcoin was not doing well during this period, we are able to get a positive return by using our optimized linear regression strategy. So finally, let's look at the rules of entering the trade using this strategy. If you're familiar with my backtesting strategies, you know that we define a backtesting class which derives from a base strategy, and in the backtesting class we define the variables here, and then finally we have this run class where the way we close our trades is to look for take profit and stop loss, which I won't go into detail in this video. But then we have this condition which we use to enter our trades, which is the main thing that differs between one strategy and another. So in this case, we have two conditions. One is where we generate a random variable which can be 0 and 1 using this function, and if the random variable is 1, and the second is this Boolean variable where we say if the slope is greater than the threshold that we define. If those two conditions are satisfied, then we enter a trade. And with those two, and this is a simple sort of one line change over the purely random strategy where we enter if the random variable is 1. But with that simple one line change, we were able to optimize that change and make a much more profitable trading strategy. Hope you enjoyed this video, and please like and subscribe if you like to see more backtesting of trading strategies in Python. Thank you.